We are going to carry on with lecture number 2 based on chapter 3. And this is roughly where we were at the end of our last class. I'm going to spend a few minutes recapping material from our last class. So what did we spend time doing on Friday? We studied this idea of the production possibilities frontier, correct? And what is the definition of the PPF? It's a line that passes through all the quantity combinations of the two goods in this two-good economy that can be produced by full utilization of the economy's resources, correct? So a point like A or B or C, D, E, F, etc., these are all quantity combinations that would, in fact, exhaust this economy's resources. Right? Now remember, we have this big simplification, that is, that the economy is a two-good economy. We made a further simplification, if you recall, and that is that there was just one resource, labor. Correct? Now we studied that, or we learned last Friday, that there are these two important properties of the PPF. And the first property of the PPF is that it is negatively sloped. And what's the reason for this negative slope? In one word? Scarcity, exactly. See, the implication of the negative slope is that in order to make more cell phones, this economy has to give up some DVDs. And the only reason we have this type of trade-off is because of scarce resources, labor in this case, correct? The only way that you can make more of one good is by producing less of another, right? The other property that we learned is that the curve is not a straight line, rather it is concave to the origin, right? In other words, if you were to stand at the origin of the graph, which is this point here, so if you were to stand here and look out at the curve, it would look concave to you, right? And what's the reason for the concavity, somebody? What's the reason for the concavity? The fact that all workers are not alike, correct? In other words, workers are not homogeneous. You have workers who are very good at one good and bad at the other. And at the other extreme, you have workers who are very good at the second good and very bad at the first one. Correct? And because you have this type of dissimilar kinds of workers, you have a concave PPF. And of course, the implication of concavity is you have increasing opportunity cost. In other words, as this economy produces more and more cell phones, it becomes progressively more and more expensive to make cell phones in terms of DVDs given up. Do you see this in this graph? So when the economy goes from 0 cell phones to the first million cell phones, it gives up just 1 million DVDs, right? But when this economy goes from 1 million cell phones to 2 million cell phones, point B to point C on the PPF, we find that the opportunity cost of doing so is 2 million DVDs, correct? More than before. And when the economy goes from 2 million to 3 million cell phones, from point C to point D, well, the opportunity cost now is 3 million DVDs. So we have this progressive increase in the opportunity cost of producing cell phones in terms of DVDs given up. Correct? And that's the implication of concavity. If we had a straight line PPF, then the opportunity cost would be constant. Do you follow me? If we had a straight line PPF, as we increased cell phone production from 1 million to 2 million to 3 million, etc., we'd always need to give up exactly the same quantity of DVDs. There'd be constant opportunity cost. right? Now, what's the reason for the increasing opportunity cost again? The fact that resources aren't homogeneous. In other words, resources aren't alike. That's the reason for the concavity of the PPF. Now, I'd like you to focus on the range C to D quickly, right? So let's say that the economy is currently at point C and then moves to point D, right? So it produces an extra million cell phones by giving up 3 million DVDs. But what if I were to ask you the opportunity cost of making just one extra cell phone in the range CD of the PPF. In other words, I don't want to make an extra whole million cell phones. I want to make just one extra cell phone. What would be the opportunity cost of doing that in terms of DVDs given up? Now, 3 DVDs. How do we arrive at 3 DVDs? Well, the logic we used was quite simple. We said that the opportunity cost of 1 million phones was equal to 1 million, or rather 3 million DVDs in that range, correct? How do I convert this 1 million into 1? How do I go from here to 1? By dividing by 1 million, is that correct? Right? So if I divide that 1 million by 1 million, I get 1. But I have to do the same thing to the number on the other side of the equal sign, correct? So I'd be dividing this 3 million by 1 million as well, and I'd arrive at 3 DVDs. Is that correct? Now, if you look at this little triangle that's been formed here, triangle CGD, and how do I form this triangle CGD? I draw a straight line between point C and D, right? And then I go vertically down from point C, and then I go horizontally leftward from point D, and the 2 lines meet at point G. This here is a right-angled triangle, right? And if I asked you to calculate the slope of CD, this slope would be equal to rise by run, as you all know. And what's the rise in this case? The rise, of course, is CG, and the run is DG. And what are these numbers? CG happens to be 3 million, and DG happens to be 1 million, and you're left with 3, correct? And what is this 3 again? This 3, remember, is the opportunity cost of 1 phone. It's the opportunity cost of making 1 phone, on average, in that range CD of the PPF. Is that correct? Right? Now, I'm going over material that we covered last Friday, but since we missed class on Monday because of Martin Luther King Day, I'm just refreshing your memories a little bit, okay? Now, let's say that instead of going from point C to point D, we were going from point D to point C. In other words, let's say the economy were at point D to begin with, and now the economy wants to give up some cell phones to produce more DVDs. Yes? Could you work out the opportunity cost of making 1 additional DVD? Not the whole 3 million, but just 1 additional DVD in terms of cell phones given up. Would
it be a third of a cell phone?
It would be a third of a cell phone. Exactly right. Because how would you write this? You would say that the opportunity cost of 3 million DVDs is equal to 1 million phones. Is that right? In that range, C to D, correct? But how do I go from this 3 million, how do I go from there to 1? I need to divide by 3 million, is that correct? I need to divide by 3 million. And when I do that, I have to divide the 1 million by 3 million also, correct? And what do I end up with then? This will become 1 by 3. Is that right? You all with me here? So what is the opportunity cost of making one more DVD in terms of cell phones given up in that range? DC of the PPF? 1/3 of a cell phone. Am I understood here by everyone? Now what is that 1/3 in terms of a slope? Well, that 1/3 would be this slope right there. You see that slope there? Now to figure out that slope, you'd have to turn your head to the side, and in a sense view the triangle that way. And when you view the triangle that way, what's rise and what is run? Well, if you look at it sideways, remember you're trying to figure out the slope of basically the angle GCD, right? You're trying to convert angle GCD into a slope. Is that right? And what's the rise in that case? GD. And what's the run? CG, correct? And so that would be GD divided by CG, and GD is 1 million, and CG is 3 million, and so you have 1 million divided by 3 million, which is 1/3. Are you managing to understand this, all of you? Now, remember, it's not coincidental at all, but 1/3 happens to be the reciprocal of 3, isn't it? Now, what was the 3? Do you recall what the 3 was? Well, 3 DVDs is the opportunity cost of making an extra cell phone, correct? And so the reciprocal of 3, 1 by 3, happens to be what? It's the opportunity cost of making the other good, meaning DVDs, in terms of cell phones given up. It's always going to be like this. Okay? Now let's take a second here to digest this, maybe 10 seconds. Okay? Does anyone have a question here? Remember I did say that economics was the most rigorously logical, perhaps mathematically logical of all the social sciences, right? And some of you are mathematically inclined, then you might become interested in economics and have to pursue graduate studies in it or something in the future, right? I know this stuff doesn't appeal to everyone. It doesn't. Some people prefer wordy arguments rather than mathematical ones, right? But I hope you're all understanding this, right? So we're trying to figure out the opportunity cost, and now we've established that opportunity cost can be viewed as a slope, right? The slope of line CD in some sense, right? And that's what's being discussed on this slide, okay? And that's exactly what I said, the reciprocal. You follow me? Now let's talk a little bit about economic growth. Economic growth, which we will touch upon later in this course as well in a more macroeconomic sense. Later on, we will define economic growth as an increase in the size of the nation's GDP. Okay? But for now, we can think of growth in terms of the PPF. Right? And how do we define economic growth? It says here, economic growth is the sustained expansion of production possibilities. What does that mean? That means that if this was your original PPF, then if this PPF over time shifted outwards like that, and then even further outwards like that, well, that would be economic growth. Correct? An outward movement of the entire PPF. Correct? Perhaps I should have drawn it down here. So this is the original PPF, this is the new one. And that could be another PPF with further economic growth. So economic growth then can be viewed as an expansion in the nation's production possibilities. right? Now, what would bring about this type of expansion? Remember, go on, somebody? What about resources? More resources, exactly. Because remember, the PPF is, in a sense, constrained by the availability of resources, right? So if the economy somehow develops, gathers, acquires more resources, well, this will lead to its PPF shifting outwards. In other words, points like this, which were unattainable when the PPF was the original solid line, correct? Right? A point like that was not attainable before, right? It lay outside the old PPF. But with rightward shift of the PPF, a point like that becomes attainable, right? So growth is then caused by an increase in resources, but it could also be viewed as an improvement in the quality of resources. So it's both quantity of resources and quality of resources. Now, what do I mean by quality of resources? Now, this very often involves improved technology. You see? What does an improvement in technology enable us to do? It enables us to produce more goods and services using the same quantity of resources. To the ability to do more with the same quantity of resources. Well, that is what an improvement in technology enables us to do, correct? So you can view technology as somehow improving the quality of resources. So a pound of steel with an improvement in technology may appear to be more than a pound of steel. You follow me? You can do more with it, right? And similarly, you can think of improvements in the quality of labor as well. A worker may seem like more than a worker if this worker has the opportunity to work with improved technology, better machines. You follow me? If we are able to, say, work with faster and better and more intelligent computers, for instance, we become more productive, right? A worker will now seem like more than a worker, right? So it's quantity of resources as well as the quality of resources that causes, or rather improvements in both these areas, causes economic growth, rightward shift of the PPF. Now, let me also tell you that this rightward shift needn't be the shift that I have drawn here. It could also be a pivot. So you could have a shift like this. In other words, the quantity of DVDs that the economy can produce, maximum quantity of DVDs that the economy can produce, may remain the same. All the improvements may come in the area of cell phones. That too is economic growth. Correct? So we could have some type of technology, let's say, that only improves our capability or increases our capability of producing phones, not DVDs. But that too is growth. So you could have a kind of a swivel of the PPF rightwards. Okay?
What if the demand increases? Would that increase economic growth?
Not necessarily. Because you could have an increase in demand, but if the economy is constrained by the lack of resources, then there would not be a consequent increase in quantity supplied. And all that would happen is that prices would rise. Am I making sense? And now we come to the part of the lecture that will take us the most time, perhaps this class and next class. Okay? We are now going to talk about specialization and trade. And we're going to bring in two very important ideas. One is called absolute advantage. And the other concept that we shall bring in now is called comparative advantage. It says here, when one person or nation is more productive than another, and how do we define more productive? Needs fewer inputs or takes less time to produce a good or perform a production task. In other words, if one country can produce something using fewer resources, including the resource of time, then we say that that country has an absolute advantage in that good in comparison to another country. Now let me lay this out a little more clearly. Let's say that we have two nations. We have these two nations, right? And let's say, let me write this down here again. So we have two nations. And let's say that there are two goods as well, and the two goods are apples and oranges, okay? And let these two nations, for example, be the US, and since we are here at the border with Mexico, Mexico. US, Mexico, the two countries, two goods are apples and oranges, okay? So let's say that the US takes one worker to make 1 pound of apples, and let's say that Mexico takes 2 workers to make 1 pound of apples. Now, given these facts here, which country would you say has an absolute advantage in producing apples? The US, correct? Why? Because the US is better than Mexico at making apples. Now, when I say better, what do I mean by better? Takes fewer resources, right? Only 1 worker needed in the US, whereas 2 workers needed in Mexico to make the same quantity of apples, 1 pound of apples, that is. Correct? So this tells us, this fact here, or these facts here tell us that the US has an absolute advantage in apples. That's the meaning of absolute advantage. Is that understood? It's quite simple to understand, right? One party is better than another party in something, that party has an absolute advantage in that good. Now, it could well be that the US is better than Mexico in oranges as well. So let's just say that the US takes 2 workers to make 1 pound of oranges. And Mexico takes 3 workers to make 1 pound of oranges. Now, given these numbers here, we would deduce that which country then has an absolute advantage in oranges? Which country has an absolute advantage in oranges? The US again, correct? So we have a story here where the US has an absolute advantage in both goods. The US has an absolute advantage in both goods. Now that's possible. It's possible for one party to be better than another party in everything. But now the question arises, is there any benefit to these two countries trading with each other? Now somebody said no. In fact, now that no is an answer that economists or even lay people gave more than 200 years ago. In fact, back then in the 1800s, perhaps the 1700s even, people believed that if one country was better than another in everything, what's the point of trading? You can do everything yourself. You're better than the other party in everything. But then it was proved that that, in fact, was a false answer. That's wrong. You see, you may be better than another party in everything, but it may still pay for you to specialize in one of the two things and leave the other thing to the other person. and then engage in trade. Let me give you an example that I've been giving to my classes for more than a decade. Let's consider a big, strong sports figure, professional basketball player. Okay, I'm not a big watcher of sports. I couldn't tell you any names, frankly. I'm a nerd. But let's say that you have this big guy, call him X. Okay, right? He's strong and he plays better basketball than your average Joe. He's also a big, strong guy, so chances are he could mow his lawn a lot faster than the average Joe. I'm assuming here that the lawnmower requires a little bit of strength to maneuver, etc. He's a big guy, he can do that faster as well. Is that correct? Now, why doesn't he do both tasks? Why does he specialize in just one and leave lawn mowing to somebody else? Now, the answer isn't, oh, he can afford it. Now, that's really not the answer. Why does he choose to specialize in basketball, leaving lawn mowing to somebody else, even though he is better at both tasks than your average Joe? So that he can spend more time in basketball, either playing or practicing, because all of that is more valuable to him. Is that correct? Now, in terms of opportunity cost, could you perhaps say that for him, the opportunity cost of lawn mowing in terms of basketball practice, basketball income revenues given up is very high? Am I making sense? Every hour that he spends lawn mowing is an hour away from basketball practice. And that he finds extremely expensive. Am I making sense? Right? So it really all boils down to how expensive an activity is in your eyes. Expensive in what sense? In an opportunity cost sense. How expensive is an activity in terms of the other activity given up? Now, we would say here that basketball player X has what is called a comparative advantage in basketball compared to the average Joe. He has an absolute advantage in basketball and lawn mowing, but average Joe has a comparative advantage in lawn mowing. Right? And this will become clearer as we proceed. So basketball player X has a comparative advantage in playing basketball. Average Joe has a comparative advantage in lawn mowing. Hence, the two specialize in these respective activities. And then engage in trade. What sort of trade is that? The basketball player hires the lawnmower, and the lawnmower buys tickets to the basketball game. Is that correct? Now, this is the sort of idea we're going to lay out now. Okay? And I'm now going to introduce to you the idea of comparative advantage formally. Now, instead of two countries, we have here two people. We have Liz and we have Joe, right? And both these guys run smoothie bars, their own smoothie bars. And these smoothie bars, two goods are produced. It's called a smoothie bar, hence, of course, you have to have smoothies on the menu. And salads as well. And here we have Liz's production possibilities. It says here that in 1 hour, which is 60 minutes, Liz can produce either, remember the key is either, 30 smoothies or 30 salads. Now, could you first identify in this case the particular scarce resource? What is the scarce resource in this example of production possibilities? Time, right? What's time? Is that correct? In that 1 hour, which of course is a scarce resource in this case, right? Well, you can think of it as time. You can also think of it as labor, really, because it's labor hours, right? So we're talking about Liz's labor hour, 60 minutes of her labor. You can measure labor in terms of time, correct? So in this 1 hour that is available to Liz, she can do either 30 smoothies or 30 salads. Could we draw her production possibilities frontier? So let's call this the smoothie axis. And let's call this her salad axis. And what are the endpoints of her PPF going to look like? Well, she can either produce 30 smoothies and no salads, and that would be a point like this here, which is point 30, 0, right? You always write the x coordinate first, right? And the other extreme would be what? 0, 30, which is no smoothies, 30 salads. So we have the two endpoints of her PPF. What about the PPF itself? It would be a line joining those two endpoints, but my question to you is, would it be concave to the origin like the PPF we've previously seen, or would it instead be a straight line? You say straight line. Why do you say straight line? Well, what was the reason for the concavity of the PPF that we saw before? That resources were not homogeneous. There were different kinds of workers, correct? But here we are talking about minutes of Liz's labor. And is there anything heterogeneous about it? They're all her labor, so they must all be the same, correct? All those minutes of labor must be the same. So here we're talking about a case of homogeneous labor. It's her labor, correct? So therefore, the PPF would be a straight line. Am I making sense to you? So we would then simply join those two endpoints. We would draw a straight line between these endpoints. And now I'm going to ask you a question, and that is, what is this slope equal to? What is that slope equal to? Think of that as a right-angled triangle. And so think of rise and run and tell me what that slope is equal to.
Is it 1?
It is 1, because what's rise? The rise is this. That's the rise. And what's the run? The run is that, correct? So rise by run is 30 by 30. So the slope is 1. And what's the meaning of that slope? We just discussed that. What would be the meaning of that slope in terms of opportunity cost?
For every one thing she makes, she's going to be...
For every one what?
One smoothie she makes, she'll be losing one salad.
Exactly. Right? We've learned that the slope of the PPF has an opportunity cost meaning. Is that correct? Do you recall this? So what is the slope? What is that slope equal to? It's the opportunity cost of producing one more good that's measured along the x-axis in terms of the other good measured along the y-axis. So that slope would be the opportunity cost of making an additional smoothie in terms of salads given up. And this makes perfect sense, right? Because in those 60 minutes, you can make either 30 smoothies or 30 salads. This implies that it takes her 2 minutes to make either a smoothie or a salad. If she decides to make an extra smoothie, she'd be pulling 2 minutes out of salads and bringing those 2 minutes into smoothies. When she pulls 2 minutes out of salads, she gives up a salad, since it takes her 2 minutes to make a salad. And those 2 minutes are now no longer available for salads. Is that right? That's another way to think about it. Correct? What about this slope? Let me show you what slope. Let me change my pointer color. What about this slope? What would that slope be? How would you make meaning of that slope? Firstly, what is that slope? Well, to figure out that slope, you'd have to tilt your head to the side, as you've done before. And what's rise and what's run now? Well, the run that we've labeled here would now become the rise, correct? And the rise labeled here would become the run. But we still end up with 30 by 30, which is 1. Now, I've mentioned before that that top slope is actually the reciprocal of the bottom slope. Correct? But in this case, since we're talking about the number 1, the reciprocal of 1 is 1. Right? So the opportunity cost of making an extra salad in terms of smoothies given up is 1 smoothie. and the opportunity cost of making an extra smoothie in terms of salads given out. This is one salad. This is Liz's story. Now let's look at Joe's PPF. And here are Joe's number. Takes him rather, 10 minutes, or rather, hang on. In an hour, it says, in an hour, Joe can produce either 60 smoothies or 30 salads. Sorry, not 60, 6. 6 smoothies or 30 salads. So what are the endpoints of Joe's PPF? Well, let's draw that quickly. So this is the smoothie axis, and this is the salad axis. So what would be the coordinates of the endpoint on the smoothie axis? 6, 0. Isn't that right? 6, 0. And are you all with me here? Because she can produce, or rather he can produce 6 salads and, 6 smoothies, no salads, right? Or he can go and produce 0.30. And once again, we're talking about a homogeneous resource here because it's Joe's time we're talking about. So that all his minutes of labor are exactly the same as each other, right? And that would give us a linear or straight line PPF. Not a concave one, but a linear PPF, right? So let's draw his PPF. And I'd like you now to think of this slope here. What is that slope equal to? Rise by run, somebody tell me. What's that slope equal to? Rise is, run is 5. And what's the meaning of that 5 again? What is that as an opportunity cost? It's the opportunity cost of producing one extra what? Smoothie. The good being measured along the horizontal axis, correct? So Joe, in other words, would have to give up 6 salads in order to make a smoothie. Correct? What about the top slope there? Let me change in colors. What about this slope here? Now to do that, you'd have to tilt your head, and what was rise before becomes the run, and vice versa. And what would that slope be? How much? 6 by 30, which is 1 by 5. Notice the 1 by 5 is the reciprocal of 5 by 1, or 5, right? So what's 1 by 5 then? How would you interpret 1 by 5? It's the opportunity cost of producing an extra what? Salad in terms of smoothies given up. Is that correct? So this 1 by 5, what 1 by 5 is this? What are the units of measurement here? 1 by 5 what? Smoothie. And what's the 5 here? The units of measurement are salads and smoothies, right? Are you all with me here? So now I'm going to ask you, but first I'm going to define comparative advantage. So when does a party have a comparative advantage? Comparative advantage as opposed to absolute advantage. Absolute advantage we've already dealt with. So how do you figure out comparative advantage? Who has a comparative advantage in, let's say, smoothies? The answer is the party with the lower opportunity cost. So who has a comparative advantage? The party with the lower opportunity cost. Hence, basketball player X had a comparative advantage in basketball. Why? Because it was cheaper for him to play basketball in terms of lawn mowing given up. It wasn't really giving up much when he was giving up lawn mowing. He was saving $40. That's the sum he'd have to pay someone to mow his lawn, right? So an hour spent in basketball only cost him $40 in terms of lawn mowing given up. That's a very small amount, am I correct? Compared to that 1 hour of practice he puts in, which then raises his earnings by a few $1 million. Correct? So it's very cheap for him to give up the lawn mowing. So his opportunity cost of an additional hour of basketball practice is very low. Correct? So how do you define comparative advantage again? The party with the lower opportunity cost has a comparative advantage in that particular good. Right? It says here, Liz's opportunity cost of a smoothie. How much is it? How many salads does she give up to make a smoothie? 1, right? And what is Joe's opportunity cost? 5. So which is smaller? 1 is smaller than 5. Is that right? Hence, we say that Liz has a comparative advantage in producing smoothies because Liz gives up less salads to produce an extra smoothie. Correct? Given this, can we now figure out the party who has a comparative advantage in making salads? We know we know now that Liz has a comparative advantage making smoothies because she gives up less salads to make an extra smoothie. Her opportunity cost of making a smoothie in terms of salads given up is lower than Joe's. But who has a comparative advantage in the other good? Who has a comparative advantage in making salads in terms of smoothies given up? Joe's opportunity cost of making a salad we worked out is 1/5 of a smoothie. Liz's opportunity cost of making a salad is a whole smoothie. We know that 1 by 5 is less than 1. So Joe has a comparative advantage in producing salads. Correct? So we've established here that one party may not have a comparative advantage in both goods. It's not possible. Why is it not possible? I'll tell you why. Mathematically, how do we work out Liz's comparative advantage? We worked out Liz's comparative advantage by comparing the numbers 1 and 5. So let me write this here. So for Liz, we had the following. We said 1 is less than 5. Hence, Liz has a comparative advantage in smoothies, right? And for Joe, what were the numbers? To figure out Joe's comparative advantage, we compared what numbers? The reciprocals of these. So the reciprocal of 1 was 1, but the reciprocal of 5 is, and when you take reciprocals, what happens to the direction of inequality? Reverses. That is a mathematical truism. When you take reciprocals of numbers, the direction of inequality simply reverses. Do you see that? So therefore, it is impossible for one party to have a comparative advantage in everything. Do you get me? Not possible. Whereas it is possible for the US to have an absolute advantage in apples and oranges. It's possible for one party to have an absolute advantage in everything. It's possible for basketball player X to have an absolute advantage in basketball and lawn mowing compared to the average Joe. But the basketball player has a comparative advantage in only one item, and that is basketball. Average Joe has a comparative advantage in lawn mowing because he gives up very little basketball by lawn mowing. Correct? So this is how we establish comparative advantage. Now in the last 6 minutes or so that I have, let me proceed from here. Right? So here are the two PPFs. We've already drawn these, correct? So this is the blue line is Liz's PPF, the red line is Joe's ppf. And let's just assume that Liz produces at that point shown right here. In other words, Liz chooses to divide her time equally between smoothies and salads. She makes, in other words, 15 smoothies and 15 salads. She devotes half an hour of her 1 hour to one good and half an hour to the other. Now, Joe, on the other hand, we assume, produces here. Now, what's his division of time like? He's spending the bulk of his time, 50 minutes. He is spending 50 minutes on smoothies. It takes him 10 minutes to make a smoothie, remember? Right? And he's spending only 10 minutes on salads. This is how he chooses to divide his time. He's producing, therefore, 5 smoothies and 5 salads. Correct? What is their combined output in this case? Their total output of smoothies and salads, how much is it? Well, combined output is equal to 15 plus 5 equals 20 smoothies. Oops. 20 smoothies, and we have again 15 plus 5 equals 20 salads. And now let me show you that there would be a gain in terms of production, and therefore a gain to society, if these two people were to specialize in the good in which he or she has a comparative advantage. So let's say that we ask Liz now to specialize in the good in which she has a comparative advantage. What good is that? Which one? Smooth. So let's say that we ask Liz to specialize in only smoothies. So we move her from that point on her ppf, we move her to this point. And we ask Joe to specialize in the item in which he has a comparative advantage. What good is that? So we basically move him this way, here. Right away, you can see that their combined output of these two goods right away goes up to, what's their combined output now, post-specialization? Isn't it 30 smoothies and 30 salads? Do you see that? 30 smoothies and 30 salads is their combined output, that joint output. Now, isn't that bigger than before? So right away, I have demonstrated to you that society as a whole gains from specialization. There are more smoothies and more salads available for our consumption. Right? So this is a clear gain to all of us from specialization. Correct? But does it gain how do these two people gain? We know that society gains from increased production. But how do these two people gain is the question. Correct? And that I will leave for our next class. Okay?